Hi, welcome YouTubers. I've been working on some MIDI projects recently and I thought I might share these in case anyone's interested. So what we have here is something from Seed Studio. It's a Seed Studio Xiao Midi synthesizer. It's a hardware MIDI synthesizer. They're relatively cheap compared to professional hardware synthesizers, and you can get these for between $20 and $30. Now what you can do with these is, for example, if you've got some MIDI files, you can play them on a DAW, digital audio workstation software on your PC, and play them individually through onto either the speaker here, or alternatively you can feed them into a mixer or an amplifier by using this 3.5mm audio socket here. So I made a little diagram showing basically what happens in this case. So this is our case 1, which just uses one of these. Later on I'll show a second case, case 2, where you can use several of these. For example, I've actually got 6 of them, and often use projects between 1 and 6 of these at the same time. So first of all, case 1, you have your PC here and loaded up with some DAW software. I've been using some free software, which is Traction Waveform 13, the free version. And then we connect this up excuse me, to the hardware MIDI synthesizer using this USB-C port here. So this allows us to stream MIDI from here to here, which is basically just very much like a UART serial protocol, and also providing power, taking 5 volts USB power to power up this unit as well. Now we have some software here. The good thing about this way is we're using a library from GitHub, a very comprehensive library which is called 47 Effects, so thanks to them. And this can give us basically very easily what we call a class compliant driver. So this means that when we plug this USB into a PC, it will automatically add it to the devices that the operating system can understand. In my case, it's going to be Windows and Device Manager. And we have some software on here to do that. I borrowed some and modified some software from Kevin at DIY Electro Music. So thanks to Kevin for that. And then once we start playing something on the DAW, the USB streams the MIDI data to here. The hardware synthesizer synthesizes it. In here there's a hardware chip to do that. And that is the SAM2695 hardware MIDI chip. And it will produce audio. Now there's an internal speaker available on these Xiao modules, which is great for just experimenting with. If you want something a bit more quiet, higher quality output, then you can take an audio cable and put this into an external amplifier or an external mixer, as you wish. Okay, so that's first part here, which is telling you about case 1. And following case 1, we've got case 2, would you believe? So here's case 2, and here, for example, we have an example of what case 2 looks like. Let's turn it the other way around, perhaps. So case 2 doesn't use just one of these hardware synthesizers. Here I've got the other 5 that I have, and the principle here is that we have a Xiao module here, and this acts as a host. So according to our diagram here, we have the same sort of thing. We have the PC with its installed DAW software, and we connect to it with a USB host. So the USB host connects into the Xiao module here. It's a USB-C connector again. But here, this is a separate module. The processor here is actually the same processor that's in all of these, but here I've got it installed on the Xiao expansion board, just for a bit of convenience, and I'm able to put a little user interface on here. Let's bring that down a little bit. So here's the Xiao expansion board. We've got little OLED on here, and then we've got a rotary encoder to let us play with some menus on this little display, get some feedback. And basically the USB cable goes in here. We use some different software here, which I've also got on GitHub. Both versions of the case 1 software and the case 2 software I've got on GitHub available. And then we go from here into a 3-way bus. So I've got 1, 2, 3 lines, and basically just the one on the left here is 5 volts for power. I'm using an external supply for that so that I don't overload the power on here. Just being cautious in that regard. The next one here is just the serial out. It comes out on a TX6 pin of the Xiao processor, which the processor in this case is the samd21 in all cases. And the TX6 goes into this common bus and then goes into however many individual synthesizers that you want to add. With the MIDI standard you can have a maximum of 16 channels, and I've been able to demonstrate it quite easily on 6 of them so far. So TX6 just gets fanned out to RX7 on each of these, so they all receive identical MIDI streams. And the way that they can do different things is so that here on the individual processors I've mounted a little daughter board on top, and you see that daughter board has a rotary hexadecimal switch, so we can change this to go and choose between channels 1 to 16. On this hex switch they're actually numbered 0 to 15, but that just corresponds to 1 to 16 in terms of the MIDI specification, which uses the range 1 to 16. And we can then, once the stream comes in here, the switch, say when it's pointing to channel 5 for example, it will only receive messages meant for channel 5. So it will just basically, if this one was set to 5, it would solo the information for channel 5 only. If this one was set to channel 2, it would solo and disregard all the information for all the other channels apart from channel 2, and up to as many as you want, say a maximum of 16 in the case of the MIDI specification. You can play it through again all the individual internal speakers, or you can add a 3.5mm audio cable. These are all mono, by the way, so just single channels each time, and then you can mix all these together if you wish on an external mixer or amplifier. So that's what we're going to do in case 2. So case 1 is for a single one of these, and case 2 is for multiples of these modules. Okay, now next thing I want to show is what happens in Device Manager in Windows when you connect up case 1. So here we have case 1, we've just got a single hardware synthesizer. And what you should do is expand the entry for sound, video and game controllers. And there's nothing in here at the moment which shows you a MIDI driver. So let me now plug this in. And this is the beauty of the class compliant library, which lets us get USB MIDI streaming compliance here. We see the Xiao now appears as a sound device, and M0 is probably for MIDI instance 0 on the list there. So we're able to select this entry Xiao M0 in any of our DAW software that we want to send MIDI streams to. The other thing that will happen, if you look under ports, the processor on here will be assigned a COM port number, and this is fairly random, and in this case it's COM port 25. So two things actually change. If I unplug again, see that there's no COM ports available. The COM port's completely gone, and the Xiao MIDI driver's gone from the sound devices. Connect back up, and we get Xiao M0 and USB serial device COM25. So that's typically what should happen when you plug into Windows. The next thing I want to do with case 1 is play a demo. So I've got some old music here, the famous Pachelbel's Canon in a MIDI file, and we're going to play this on the single MIDI synthesizer, and at the moment it's set to channel 4, track 4. So track 4 here is the viola, so let's see if we can get some music out of the internal speaker for that. It doesn't start till bar 5, so I'm going to start at bar 4, and here we go. Now originally I was hoping to just change this number, so let's have a listen to track 5, and the switch on here, the hexadecimal switch, is only red on power up reset, so I then reset this case 1 single synthesizer and then play, and it should play track 5. But unfortunately it doesn't. There is a bug here where the DAW software doesn't recognise the change. So here I have to quit the DAW and then go back in again. Let's go to bar 4 and start playing again. And this time track 5 should play. So now it's a cello, and you can see that we managed to pick out a different channel by changing the switch on the little daughter board. So that's how we demo case 1 with traction waveform. And now we're back to case 2. We're going to do a demo of case 2. So case 2 is where we've got multiple synthesizers. You see they've all got these little daughter boards on them. And so I'm going to choose to select on number 1 here, I've got it selected to track 1, channel 1. And on 2, track 2, channel 2, 3, set to 3, 4, set to 4, and 5, set to 5. Here we have the little display on, because this is the Xiao expansion board. Now let's see what happens when we power that up. We're going to power 2 things up. First of all, we're going to power up all the individual synthesizers. So 5 synthesizers get powered up from a separate USB, and then the host here, well, it's actually a USB device, but the one that supplies the stream to all of the 5 devices through this simple 3-way bus is on here. Now we have a little display on there. We can change through the entries using this rotary encoder here. I've got just a test mode. It's called My LED. It's going to turn on the LED and turn off the LED. But more importantly, for the MIDI test, it's got an uptime count and it's got a through count here, which is 0, and that just counts the number of MIDI bytes that go through the system. So now I'm going to run up the waveform free software with the same Pachelbel, and on track 1 we got some piano. That's on first. And now you can see the byte count, through count increasing here. This is handy to know that things are going well. And then we get 3 more channels coming in now. Violins on track 3, viola on track 4, and cello on track 5. So that's a quick demo of case 2 using multiple synthesizers. And finally, I want to just say a few words about how I modified the standard Xiao hardware synthesizer. So with a flat bladed screwdriver you can actually take this section off. So originally these were connected like this, and I just put a hacksaw through there to get some more access. Behind here you can see the small internal speaker, and then if you're interested, the actual SAM the MIDI synthesizer chip, which is the SAM2695, is just here. And these 4 switches actually go to the same place as the daughter board switches are made. So basically to get 16 combinations you need 4 bits, so 2 to the power 4 gives you 16 combinations. And unfortunately these switches, they go to D0, D1, D2 and D3, but they're just momentary push buttons, so you can actually use them if you're really dedicated enough to make a selection, but it's much easier to put these in parallel with these switches and then just select a single number using the rotary switch instead of 4 push button switches. So that's one thing, that's the switch interface. And when you buy the seed Xiao synthesizer, it comes with a different processor. It actually comes with an ESP32C3 processor, which comes with its own little Wi-Fi antenna. But unfortunately this is not compatible with the 47 Effects library. It needs the samd21 module, and here's a samd21 module. So if you want to follow this kind of build and get your Windows or Apple type MIDI class compliant driver, you'll have to replace this one with a Xiao samd21, which these will cost you between about $5 and $10 each. Now the modifications, say, have cut this part away. Basically this processor was in here before. I take this one out and I replace it with one like this. Now the original ESP one, it does have boot and reset buttons on the Xiao module, but unfortunately the samd21 comes with no switch, so I've added one. Because quite often during development you want to have a hard reset for your processor. Basically you want to access these 2 little pads. Very difficult to see at this scale, but there's 2 pads, one pad here and one pad here, just next to the USB-C connector. So you need good soldering skills for this, and use some wrap wire, and then I've just taken this up to a separate push button to give me reset action, and just mounted it on a bit of white foam adhesive. So this will save you a lot of time if you are actually going to do some development, giving you the ability to reset your processor. Otherwise you need to be creative and get a paper clip and just touch those 2 pads. But there's different kinds of reset modes. One is just a single touch, and then the other one's like a double click on a mouse where you have to touch twice to get a full reset. And that can be even more tricky, so it's quite easy if you add the switch, because you just need to do a double click to get a full reset, and then you're ready to start programming it again. So I've already got samd21 in here. I've got the switch. The reason I took this out was to gain some access space. Basically the speaker can go back in on its own, like that. And then I built a little daughter board with the 4 switches from the rotary switch going to D0, D1, D2 and D3. And a little bit fiddly to make, but if you've got good skills, you'll be able to make one of these. And just mount that in there. Now once that's available, you just can change whatever channel you want to receive using the screwdriver, and then just do a reset on the switch. Depending on your DAW software, you may need to reinitialize your DAW software. If anyone knows how to get around that problem of having to reinitialize the likes of Traction Waveform 13, that'd be great if you could leave a comment. Otherwise I just stop and start the program. So yeah, that concludes what I want to say about case 1, and maybe do another video showing case 2 with multiple versions of these later. Okay, thanks for listening. Bye.